Okay, let's dive right into this. Welcome to today's Explainer, where we're digging into some genuinely fascinating new research. We're talking about something that could fundamentally change how artificial intelligence writes and debugs software. We're breaking down a recent paper from researchers at Shanghai Jiaotong University, and it's called LLM Agents Can See Code Repositories. Basically, this research tackles one of the absolute biggest bottlenecks in software engineering AI today, and it does it by asking a surprisingly simple question about how we, as humans, actually process information.
So think about it for a second. If you're a developer, how do you navigate a massive, completely unfamiliar code base? Imagine just opening a huge new repository for the very first time. You don't just open a terminal and start reading line 1 of file 1 all the way through to line 1,000,000. I mean, no way, right? Instead, you naturally look for visual structures. You open up your IDE, you scan the folder hierarchies, maybe you glance at the dependency maps. You're visually orienting yourself to figure out how all the different pieces of the puzzle fit together before you ever dive into the actual syntax. This visual intuition is just completely central to how humans understand complex systems.
Section 1. The AI blind spots.
And this brings us to a massive disconnect in how our current tools operate. On one side, we have human developers relying heavily on visual folder hierarchies and dependency relationships. But on the other side, we have traditional AI coding agents. Up until now, these large language model agents have consumed repositories almost entirely as flat text. So if you want an AI agent to fix a repository-level issue, you're essentially forcing it to read an entire repository as a massive, flat string of text. This is a tremendous blind spot. Not only does this rob the agent of that overarching structural context we just talked about, but forcing an agent to read a whole repo's text results in absolutely massive token consumption. It's literally like reading the entire encyclopedia just to find a recipe for pancakes. It's just incredibly inefficient.
Section 2. The Vision-Only Trap.
Now, what's really interesting is how we test this problem. With the rise of multimodal large language models, AI that can process images as well as text, it seemed like an open question: can agents benefit from visual representations of repositories? So the researchers evaluated 4 recent multimodal models. The initial hypothesis was probably that simply giving the AI eyes would fix the whole thing. But, surprise twist, a strictly vision-only setup actually makes things worse. It degrades the agent's accuracy and, believe it or not, increases the token cost. Why? Well, because when the AI only sees an image of the code, it lacks sufficient symbolic detail. It can't easily parse the exact text characters it needs, so it compensates by making repeated visual queries. It just keeps looking at the code over and over again, driving up costs and lowering performance. So yeah, giving it only eyes was a bit of a trap.
Section 3. Seeing the big picture. Okay, so if text only is flat and inefficient and vision only lacks detail and accuracy, where exactly do we go from here? Paper author Silan Chen perfectly captures the conceptual breakthrough that anchors this whole research, noting, if humans can see structure to understand a codebase, why shouldn't agents see it too? Chen explains that an agent shouldn't just read files one by one. It needs to see how files, classes, functions, and dependencies actually connect. I love this because it completely humanizes the problem. It's about giving the AI the same overarching map that a human developer naturally builds in their head when they look at a well-organized project. Section 4. The hybrid solution. Let's move to how this builds into the ultimate fix for repository-level issue resolution. Enter cRepo. This is a practical, hybrid text and vision design. It doesn't just throw away the text interface, because as we just learned, agents really need that symbolic detail to actually write and edit code. Instead, it integrates visual graphs of the repository structures as a supplementary modality. Basically, it provides a visual map right alongside the code. So the agent gets the absolute best of both worlds. It can read the exact syntax via text, but it uses the visual graph to bridge the gap in its spatial understanding of the entire project. It can literally see the architecture of the software. So the crucial point here is this specific metric, 26%. By integrating these visual graphs alongside the standard text interfaces, cRepo helps agents understand the structure so much more efficiently. In fact, input token consumption decreases by up to an impressive 26%. When an agent can look at a visual map to understand where a bug might be, it doesn't have to painstakingly read thousands of lines of irrelevant text just to find its bearings. It just looks at the map, finds the right neighborhood, and goes directly there. And honestly, this next point is absolutely vital. Issue resolution accuracy is maintained or improved. Let me repeat that. This massive 26% token savings does not compromise the AI's performance at all. It is a pure win for efficiency. The AI is doing the exact same quality of work, if not better, but it's doing it much faster and much cheaper. Why? Because it isn't wasting precious computing power reading code it doesn't even need to read in the first place.
Section 5. Next-gen coding agents. So, what does this actually mean for the future of software engineering and AI? And this brilliantly illustrates where we go from here. There are two real-world phases where C-Repo truly shines. First up is fault localization. When a bug is reported, the visual map helps the agent find the exact right place to inspect or fix much faster. It's just like a developer zeroing in on a broken dependency right in their IDE. Second is autonomous exploration. As agents get more advanced and we ask them to explore codebases on their own, the visual structure helps the agent efficiently control its exploration depth. It knows when it's dug deep enough into a particular branch of the code and when it needs to pull back and look somewhere else. These findings point clearly to a hybrid text and vision design being the new standard for the next generation of coding agents. Which brings us to a fascinating paradigm shift in how we build AI tools. We've spent years, literally years, trying to make machines better readers. But maybe, just maybe, we should have been teaching them how to look at the map all along. So I'll leave you with this question to think about as you navigate your own projects today. Will the next generation of AI coders read your code, or will they see it? Thanks for joining me on this explainer, and keep exploring.